Right, we're going to be just looking at these questions, which are going to help us in our revision for test 4 in our SLAPS course. Okay, so first question is a property mass function question. We want to find the value of A. Now we know that x can take on the value of 1, 2, and 0, 1, 2, and 3. So let's put in our x values. Okay, and we've got 0, 1, 2, and 3. And we want to find, and the property of the x equals x, the capital X equals little x, our random variable equaling one of these values. So we put 0 into this, we get a over 0 squared plus 1, which is just a. Then we get a over 1 squared plus 1, which is just a over 2. And then we've got 2, so a over 2 squared plus 1 is a over 5. And then we've got 3, a over 3 squared, which is 9, plus 1 is a over 10. And that is our probability distribution or probability mass function. So we want to find the value of a. Well, we know these probabilities must all add up to 1. So therefore a plus a over 2 plus a over 5 plus a over 10 must equal 1. Now the easiest thing to do is to put this all over tenths. So it's going to be 10a plus 5a, because timesing that by 10, timesing this one by 5, timesing this one by 2, and then we get another a here, a over 10 equals 1. So 10, 15, 17, 18a must equal 10. So a will equal 10 over 18, or that equals 5/9. Part B, we want to find the probability that x is greater than or equal to 1. Well, the easiest way to do this, greater than or equal to 1, is going to be all these values. So the easiest way is to work out less than or equal to 1, which is that value, and take it away from 1. So if we do 1 minus a, the probability that x is greater than or equal to 1 is equal to 1 minus a, which equals 1 minus 5/9, which will give us 4/9. Okay, in our second question in this series, we've got a random variable x, probability mass function p of x, described by this table, and we want to find k. So therefore, all these values here must add up to 1. So if we do part A, we know that 0.1 plus 0.3 plus 0.45 plus 0.1 plus k must equal 1. So let's add these up. That's 0.4. And that's going to be 0.5. So it's going to be 0.95 plus k will equal 1. So therefore, k will equal 0.05. Find the probability that x is greater than or equal to 3. So it's going to be equal to 0.1 plus k. So whatever your answer you got for k was, then you're going to get the answer of 0.10 plus k. And that would be follow-through marks in the test. But here we get 0.15. C, find the mode of the distribution. The mode is where the probability is greatest, so it's equal to 2. So the mode will equal 2. Because the probability there is 0.45. None of the other probabilities are bigger, so therefore the mode is 2. Find the expected value of our distribution. So the expected value is equal to the probability times the value. So we get, and they add them all up. So 0 times 0.1 plus 1 times 0.3 plus 2 times 0.45. Go on to the next line, plus 3 times 0.1 plus 4 times 0.05. Let's just work that out. So this is equal to 0. This is 0.3 plus 0.9 plus 0.3 plus 0.2 when you times these two together. So what we got? We've got 0.6 plus 0.9 is 0.15 plus 0.2 is 1.7 is our expectation. Now, if we just want one thing to do when you're doing the expectation is to check back to the question, does it make sense? Now, is 1.7 likely to be the right answer? Well, remember 2 is our modal, is the most common, so it's going to be not far from 2. And the values of the probabilities above 3 and 4 are lower than the ones below 2. So therefore, it will be probably just to the left of 2. And our answer is just to the left of 2. So There's a good way of just checking that you got the right answer. Right, in this question we have 3 green balls and 2 yellow balls are placed in a hat. 2 balls are randomly drawn. X is the number of green balls shown. Explain why X is a discrete random variable. Well, X has a set of distinct values. Okay, so what do we mean by distinct? Each value is separate from each other value and they jump from value to value. In fact, X can be either 0, 1 or 2. Okay, X can be equal to 0, 1 or 2. So the possible values of X are going to be 0 balls, green balls, 1 green ball or 2 green balls. If you're choosing 2 balls, the maximum number of green balls you can choose is 2. Obviously you could have 1 yellow, 1 green, which give you 1 green ball, and obviously you could have 2 yellow balls drawn, which will give you no green balls. So we're going to construct a probability table for X. So let's just put our values that X can be 0, 1, 2. And we want the probability that X is equal to X in the next row. Now, the probability to get no balls, that's going to be 2 yellows. Now, if we have probability of 2 yellow, yellow, will equal 2 yellows out of 5 times by 1 yellow out of 4. So that will cancel down to give you 1/10. So the probability of no green balls is 1/10. Probability of 1 green ball, well, we're going to have 2 ways of doing that. You can have yellow and green, or we can have probability of green and yellow. So yellow and green will give us 2/5 times 3/4. And probability of green and yellow will give us 3/5 times 2/4. So these are exactly the same probabilities, just written the other way around. So that's going to give us, 3/10. And that will also give us 3/10, so we'll get 6/10 the probability of getting 1. Now, if we've done this right, we should get 3/10 for our final answer for getting a green followed by a green. So probability of a green followed by a green will equal 3/5 times by 2/4. And that will cancel down to half times 3/5 will give me 3/10. So therefore, look, they all add up to 1. So we got a good chance of being correct. Find the expected number of green balls drawn. So D, so the expectation of X will equal 0 times 1/10 plus the value times the probability, 1 times 6/10 plus 2 times 3/10. So that's going to be 0 plus 6/10 plus 6/10. So the final answer is going to be 12/10, which is equal to 1.2. And we would expect it to be just slightly greater than 1 because there's the mode in the middle. Okay. And we've got the probability of 2 slightly higher than the probability of 0. So you'd expect the score to be slightly more than 1. Right, moving on to some logarithm questions now. We've got point P has x coordinate 2. Lines the graph function f of x equals 10 to the x. State the y coordinate of P. So we've got the x coordinate as 2, so what we're basically doing is doing f of 2 equals 10 to the power of 2, which is 100. So therefore the y coordinate of P is going to be 100 is our answer here. Part B. Now if we're looking at f minus 1 of x equals log x, and we want to find the corresponding point on the inverse function. Now if we draw our graph here, f of x equals 10 to the x, then what we're doing is we're putting in 2, and we're getting 100 out. Then what happens on the inverse function is, if we draw in our inverse function, what we do is we put in, actually I haven't drawn this very well. If we draw our inverse function 2, you get 100 out. The scale's not very good here, so what I want to try and do is something like that. I want to put in 100 and get 2 out, is what's going to happen on here. You do the logarithm. Okay, you're going to reverse it. That's going to be the natural log. That's going to be the log of x, and that's going to be 10 to the x. Then you're going to put in 100, and you're going to get 2 out. So our coordinates here were 2, 100. Our coordinates are here are going to be 100, 2. Remember, the coordinates reverse round when you're doing the inverse function. As an aside, if we've got this expression, 100 is equal to 10 squared, we could write this in terms of logarithms. So if we do log to the base 10, which is just log, we don't write down the base, it means log to the base 10, then that will undo the 10 to the power of 2 here. So log to the 10 to the 2. This is the inverse of that 10. So therefore you get log 100 equals just 2. It's important to realise this relationship between these two things as well. This is just an aside to just help you understand logarithms a little bit better. Right, here we go, another logarithms question. So in chemistry, the pH scale is used to measure acidity. The pH of a solution is given by pH equals minus log C, where C is the concentration of H3O+. Find the pH of the solution where the concentration is this. So we know that the pH, let's go a pen. So the pH is equal to, there's our concentration, so it's minus log of 0.00234. So let's type that into our calculator and let's put this value in. So we get minus log of 0.00234 correctly. Let's execute and we get a pH equal to 3.63 to 3SF. Part B. Now part B, we've got a constant pH is equal to 6.2, and that's going to be equal to minus log of C. Now I'll do it algebraically first, and then I'll show you how to do it using your calculator. So we've got minus 6.2 equals log C. So therefore, raise both sides to the power of 10 to undo the log, because this is log to the base 10, will give you that. So we can type in 10 power of minus 6.2, and we get C will equal 6.309 or what? 6.31 if you're doing 3SF times 10 to the minus 7. So a very small number indeed. Okay, so let's just show you how you can do that using your calculator. So if you want to go to the equation solver, so alpha A, or you can just move it using the cursor, go to solver. I'm going to type in this equation here, 6.2 equals, F equals, and what we've got, minus log of X. Press execute, press solve, and we see we get 6.309 times 10 to the minus 7. So we can either do the algebra, or you can, as you do the algebra here, or you can do it on the calculator using the equation solver. I know what most of you will plumb for. Right, nice little straightforward logarithm question here. We've got part A, use your calculator to find log of 83. So we want to do log of 83, so let's go into this part and press log 83, and that gives us 1.919 and so on. It says to 4 decimal places, and that's correct to 4 decimal places. Well, it doesn't say in part 1, but it does say in part 2. So hence, right, 83 is a power of 10 where the power is rounded to 4 decimal places. So if we raise both sides to the power of 10, the 10 undoes the log, because this is log to the base 10. Log to the base 10 is the inverse function of raising to the power of 10. So they undo each other. So therefore, these undo each other and just leave us 83 on this side is equal to that. So the way we can do this is we can work out that this value here is what you're going to raise the base to. So this is the base to 10. Now you can have logs to lots of different bases. You can have log to the base 10, or we can have log to the base e for natural logarithms. Okay, that's what we're going to raise. We're going to put this as a power of that value here. If you don't see a base, then you always assume that it's base 10. Right, here we have a Venn diagram question. And you're given lots of information about what the students study. And the best place to start is who studies all 3 subjects, if you can. So we've got biology, we got chemistry, and we got physics. And that one student studies all 3 subjects. Let's move backwards. So we've done that. Now we know that 3 students study both physics and biology. So physics and biology is this circle here, but we already got 1 of those. So we need to add another 2 to get that whole thing complete. So we can cross that out. Now we've got 4 study both biology and chemistry. So 4 in this section. So that means that becomes 3 because we've already got 1. And then we've got 18 study both physics and chemistry. So that means that'll be 17 because you've already got 1 in here. So we've done all the overlaps. Now 25 study physics. So the whole of this circle is 25. Well, we've already got 20, so we only need 5 more that do physics only and nothing else. Cross that out. 26 study chemistry. So we've already got 21 in this section, so we only need 5 more in there. And then we've got 22 study biology, so 2 off. So we've got 2 off. That's 24 off. That's 16 left over for the biology section. Okay, so we displayed all this information on the chart. Now it says a group of 63 students. It doesn't say they have to study one of those subjects. It's worth just checking that our values all add up. Let's do 16 plus 3 plus 1 plus 2. That's all that. Plus 5 plus 17 plus 5. So we've added these all up. And that comes to 49. So that means in this year group, there's going to be 14 students that don't study anything. So we've now displayed the information in the Venn diagram. So we can answer the rest of the questions. B, part 1. How many students do biology only? That's 16. Part 2, physics or chemistry. So physics or chemistry is going to be 18. Physics or chemistry, actually. It's going to be everything in here, sorry. So or means you've got to include, it could be just chemistry, it could be chemistry and biology. So we're going to add these all up. So we've got 3 plus 5 is 8, 9, 26, 28 plus 5 is 33 for physics or chemistry. None of biology, physics or chemistry. 14. Physics but not chemistry. So physics but not chemistry, well, it's the 2 and the 5, so that just gives 7. Now, if you wanted to do this question with probabilities, and you want to find the probability of all of these, we just need to divide by the total number of students. So each of these answers could be just divided by 63, and that would give us all the probabilities concerned. Right, we're going to move on now to drawing this on our calculator. So we've got y equals x minus 1 times x plus 2 times x minus 2. So let's go to menu. And my calculator's not behaving. Menu, and we want graph. And we're just going to draw. So what is it? X minus 1, close bracket, open bracket, x plus 2, close bracket, open bracket, x minus 2. Now, the question I got for you before I press draw is, where do you think these are going to cross the x-axis? You should know where these are going to cross the x-axis, because you should know if it's across the x-axis y equals 0, and if you've got all these this is in factorized form, then each of these could equal 0. So it's going to cross the x-axis at x equals 1, minus 2, and 2 is where it's going to draw. Cut the x-axis. Now you see my graph is not looking very good, so I'm just going to go to the view window, and I'm going to try standard scale and see what that does, and draw that, and I get a much better picture of my graph. So I'm going to just grab myself a set of axes. Here we go. So here's a set of axes. Draw my graph. I'm going to do it in a different color. So it's going to go like this. Now it says where it crosses the axes. Well, we know it's going to cross here at minus 2, here at 1, and here at 2. Now, if we wanted to work that out, we can use the graph solve to help us. So we want to find where it crosses the x-axis is called root. So there we go, x minus 2. Go to the next one, x is 1. Go to the next one, x is 2. Press graph solve again. We want to find the max value there. So let's look for the max value. And we get x's, because stationary points are where you got maximum and minimum. So we've got here, it asks to find that, so that's going to be at minus 0.8 7, 6.1. And then it wants us to find the minimum point. So let's go graph solve. And the minimum point here is at x is 1.5 to 2 significant figures, and y is minus 0.88 to 2 significant figures. Generally use 3 figures, but I'm just using 2 so as not to clutter up my diagram. Now I just need to find the y-intercept. There's 2 ways you can do that. Multiply out the brackets and the number at the end will be the y value, or we can use our graph solve and we want to find the y-intercept, and it gives us y equals 4. So there we go. We've used our graphical calculator to help us draw a sketch of the graph and answer this question. Better label the axes x and y, and now our graph is complete. Notice it is a sketch. When you do sketches, only straight lines have to be straight. The curve doesn't have to be perfect. The scale doesn't have to be perfect. Just need to indicate the key points.